If you see a map of the western part of Europe, you will see that not everything is together. We have the UK that is divided by the North Sea. And today in Ocean Science we will explore this sea, how it forms, why it was so important for the history of this region, and why it's so cold. So when we are talking about formation, we're talking of millions of years ago, when the continent starts the division from Pangaea to Laurasia, and the division of Europe starts, so the formation of the different seas that we have here. At one time, everything was together, Scandinavia part and the UK. But then they start this division, creating a depression here that helps to the water to come in. And this is the origin and the ancient North Sea. After this, we can move forward to 12,000 years ago, in the last ice age. Here, this was everything ice and allowed to the people to walk from one side to another. That was helpful to arrive to each part of this continent. But one time this ice age has finished, this developed in the North Sea. If we are talking about geography, the North Sea is a marginal sea of the Atlantic Ocean. As we see in maps, is everything together, but not really, because we have the UK that is divided the Atlantic part of the North Sea. The division that we can see in geography is in the south by France, Belgium, the Netherlands, Germany and Denmark. And then in the north part we have Norway, and from the other side the United Kingdom. The North Sea has in media 90 meters of depth, arriving to a maximum of 700 meters around the coast of Norway. The seabed of this sea is made by sandbanks and glacier sediments that come from the tides and the currents. And one of the questions that I have put in this video was, why is so cold? So if you're thinking in the currents that we have in this area, we are thinking about the Gulf current, so the one who brings some warm water to Europe. So this is what the winters in Europe are not so cold as other parts of the world, because this water that is warm from the Caribbean Sea and from that area of the world comes through Florida and arrives to the part that is divided from the UK. And that is the point. This sea is not in contact with these currents. So we have the UK as a natural barrier to this warm up of the water. Okay, yes, but not really. I came from the future, and the thing is, the Gulf Stream that arrives to the UK then became part of the North Atlantic current, mixing with other currents and losing the heat over the kilometers. And when this current passed through the coast of the UK going through the north, then some of this water entry into the North Sea. So this helps to don't freeze the ocean, because at that latitude we have other examples around Canada or Russia that these seas can be in a lower temperature than the North Sea, so helps to maintain a minimal temperature. Still cold, but this is a problem of other currents that come also from Norway and the mixing of the winds. So I let you with the full explanation of the video. Instead, we have a mixing with the north winds, so winds that are colder because they are near to the North Pole. Then we have another point. This sea is also cold in the summer, and you're thinking, okay, yeah, it's normal because these currents doesn't arrive and that, but thinking about it, because we are in the highest latitudes, so the sun in summer is there for more than 16 hours. So if you have a shallow water with the sun all day there, how this cannot warm up the water? The answer is not in how shallow the waters are or how many hours the sun is there. It's how much heat you have from the sun. In this case, as I said before, we are in the highest latitudes, So the rays of the sun are not directly going to the sea. So the sun is not directly up, is with an angle. So the angle has a way to lose energy when they pass through different layers of the earth. So when this ray of sun arrives to the North Sea, has not the same power as in the equator. So it's not heating the water enough. And because they are shallower, this means that the heat that arrives moves through the whole water column. It's not remaining in the surface layer, as we can see, for example, in Mediterranean Sea, that we have the thermocline that divides the warm water of the surface from the cold water of below. In this case, as we have these shallow waters in all the North Sea, the heat that arrives goes to every part of the water, and thus doesn't help to heat up the water, so remains cold as before. Not that much, but doesn't take the temperature that someone thinks that can take. When we are talking about dynamics, we see that here we have an anti-clockwise size of the currents, and they are mixing with the Atlantic and Baltic Sea, depending on the winds that come also from the poles, as I said before. And this mixing helps to different phytoplankton and animals that live there, because they are moving the nutrients from one sea to another and mixing up the different layers that they have here. And all these are natural characteristics that we have of this sea. But what's also important in history, because we are talking about the British Empire, the Netherlands, so countries that live for using their boats and going around the world. This is because the wind that they have there, they can use it in a small scale, because you can move around. It's not that deep, it's not that danger, but you have enough wind to develop your boats. And after that, in the 20th century, the oil and gas extraction was also part of this scene, arriving to nowadays to the offshore wind revolution. So we have here thousands of wind turbines that are working for the different countries. This, of course, came with a price. So the North Sea that we have today has a lot of pressures from the fisheries, from the environmental changes that are going in the world. So the heat is also going here and changing the migration of the different animals. But also the pressure of taking resources there, they are changing the environment that we had before. But in a scientific point of view, here we have a small place that can be used as a laboratory, and we can understand the mixing layers that we have in shallow waters and the connection with few water masses. So it's easier to understand and research about this. So the North Sea is not only a cold and gray sea that we have in the north of Europe. It's a sea that has history that is working until today in old ways, in the scientific and in the development of industry, and also in the environmental changes that we are going through. So that is all for today. I want really to do this video for searching how the North Sea works, and also why it's so cold. That is a thing that I need to know. And now, after this research, I know how it works in the dynamics and the heating. So that is also interesting to know. I hope that you learned something today. And if you like this content, subscribe to the channel, share it with more people, and I will see you in the next video. Bye bye!